On this Tool Tips episode of the Journey to the Baja 1000, we use index cutting to double the cutting size of the Langmuir Systems CrossFire Pro CNC plasma cutting table. Hey folks, my name is Dave. Thank you for joining us on what is now our third video on the Langmuir Systems CrossFire Pro CNC plasma cutting table. So after owning the table for a couple months now, the verdict is that I love it. There is a learning curve to get through some of the issues that some people are having with the table and especially with the fire control, but I think I have most of those ironed out. So far in my experience with this plasma table, there just aren't many things that it cannot do that the big tables can do. Obviously the main limitation is just the size of the table, 33 by 48 inches in the cutting area. Today I need to cut something that's 60 inches long, and I plan on trying to do an index cut. I'm going to use Fusion 360 and also this plasma table and see if I can't cut something that's greater than the dimensions of the table. Let's see how it works. We'll start on Fusion 360. So there are two parts that I see to do an index cut, at least the way that I'm doing it. And so there's probably different ways. This is what I'm doing. So first I'm working off of sketches in Fusion 360 because what I would usually use is I make a full body bodies, and then I make a tool path off of the face of whatever the parts are that I'm having. This time I'm using a sketch because I have this open section down here at the bottom. Here's a sketch I want to first cut, and this one is done pretty much right off the Langmuir Systems tutorials on how to cut something. I'll just run through it here really quickly. I go through the setup. I'm going to go ahead and pick this box point down here. I'm going to remove, I don't know why they have this do this, but I'm going to remove all the additional stock, and then I'm going to call this the trailing arm upper first cut. And then as I go into the fabrication and the cutting, I already have my plasma cutter selected in there. I'm cutting 3/16 still, so I'm using 50 inches for the normal cut, and the lead in and lead out, I'm using 33 inches for those. I go through in the profile. I'm just going to go ahead and select all of the lines that I want to have it cut. Now realize that if in your drawing, while you're cutting sketches, for whatever reason, if you leave a construction line in there, which normally wouldn't cut if it was a body, it will make a tool path if it is a sketch. I don't know why, so just you got to go in and erase your construction lines. Now what I want this to do is I want it to cut on the left side, which is normal, but I also want it to cut on the outside, and then I want it to string one cut to the next. I don't want it to lift and go over and re-pierce. So what I'm going to do is I'm going to go over here and grab this one, and I'm going to move it back just in line, the same side as the first cut. I'm going to do that all the way around to make sure that the tool follows the path that I want it to. I'm going to go ahead and select this contour also, and I want to make sure that that is on the inside of that cut because I want that to be an inside cut. So there, now I have all of those on there. I'm going to go onto this one here, select in computer like they tell you to. I'm going to keep the nozzle down. Let me see, 33 inches for that, 300 inches per minute for that. I will do a lead-in radius or lead-in cut at 90 degrees. I won't do a lead out, and then I want it to pierce this position right here, and you got to remember that because when I come back and do the next tool path, I'm going to do that same point, just the part inverted the opposite direction. So there, I'm going to say okay. It's going to create the tool path, and then what I'll do is I'll open up the simulation and I'll run it one time at least, and make sure as the thing goes around, it's smooth and doesn't do any kind of weird stuff that I got to go back and maybe change something. So that looks good. I'm going to go ahead and post that G code. Where I want it to go into my rear suspension stuff, trailing arms. I got 2 folders for that, and there it is, uppercase. So I'm going to post that one. Now what I want to do is I'm making these trailing arms symmetric, so I'm just going to go ahead and invert this thing. So I'm going to go back over to design, and I'm going to hit the M key, the hotkey for move, and I'm going to say let's move all of these parts. Let me zoom here. I don't want the. I'm going to cancel all that because I selected that. Such a point. I don't want a point. Move. I want to move that. I want to move that. that piece, that piece, that piece. I want to move this piece, and since it's a sketch, it's making me do this. I'm going to have to select all these all the way around. There. Now what I'm going to do is just invert this thing. So I'm going to spin it around 180 degrees. Let's put it somewhere in the middle. There. Okay, that looks good. Now I got the same part, it's just inverted. Since this thing is mirror image, I'm going to go back into manufacture now and go back to setup. Same thing. I'm going to pick that as my starting point for the sketch. I'm going to take out no edits. I'm going to call this upper trailing arm, upper second cut. Okay, and then this is where it's going to be a little bit different as I go through the fabrication and specifically the cutting of this part. I've got all the same tool stuff, but as opposed to going over here and picking my contours right now, I'm going to go over here, and this is different and not what Langmuir system tells you to do. I'm going to cut on the right side. I'm going to still put this in computer, but when I come over here and now I start selecting the contours that I want to cut, now it's going to put the arrow on the right side in relation to the cut direction. Make sure this is still on the inside, so I'll put that back on the inside. So I wanted, again, to start at this point, I wanted to cut down this, so this one over here I got to swap to the other side. Let's go in the wrong direction. I want that to be on that side, and now on that side. And then now you see, now the next time it'll cut over here. So let's go ahead and finish this up. We got all that. Keep the nozzle down. 300. If you don't select 300 there, it'll travel at 50 inches per minute between different cuts on there, which will just take a little bit more time. We'll do the lead in at 90. I'm not going to do a lead out. And again, now the entry position, I want to be the exact same point so I can find it on the table, the exact same point that I entered when I cut the opposite side of this thing. So I'm going to hit OK, and now check out the tool path for that. Again, I'll run the simulation real quick just to make sure it makes sense. Awesome, it looks good. All right, so it's just something to talk about really quickly. As I zoom in on this tool path, it has this green line right here, which is, I think, the lead in. Now realize that if I've gone in here a couple times and I said, don't give me a lead in, don't give me a lead out. I want you actually to fire right at this point right here. And for some reason, Fusion 360 still gives you a lead in at least. And so I couldn't get rid of that. I don't know why. But what the tool's going to do is going to come over here, and it's going to basically, it wants you to give you this line, so it's going to fire and cut off on the right side as it's traveling. Remember, on the other way, it was cutting on the left side. So when I index the tool, I can go in and just put the starting point at exactly the same point, and it's going to give me the same cut line. If I said cut on the left side and I came over here and indexed the tool to this point, then it's going to give me like basically a zigzag by a couple thousandths. It won't be lined up, but by doing it on the left side and then switching it over to the cutting on the right side, it lines that cut up exactly when you go back and re-zero to the same point. Okay, so the program is only part one. Let's go ahead now and do the part two of this index cut, which is setting the plate still up in the Langmuir Systems CrossFire Pro. And let me show you a couple of tools that I'm using to make sure I get that thing perfectly perpendicular to the motion of the gantry. Okay, so the Langmuir Systems is set up ready to go. I got the sheet metal on there, and you can see the problem that I have. So I'm trying to cut a piece that's about 57, 58 inches long, but the table from side to this side, lengthwise, is only 33 inches long. It's 48 inches wide. So this sheet is about 60 inches long, and it is 48 inches wide, which is your standard sheet that you can get. And so what I'm going to do is I'm going to go ahead and first try to make this sheet perpendicular as much as I can to the gantry. So I'm going to mark a line on there first, and then I'll show you how I'm going to make it make sure that it's perpendicular. All right, so now what I've done is I've used this piece of angle iron on the sheet because I want to put a straight edge all the way down the side. I could use the side of the sheet metal. I just didn't feel like it was going to be a good enough reference for me to go back to. So I did is I took my silver welder pencil, I just ran it through my angle grinder to make sure that I got a perfectly sharp, my belt sander to make sure I got a perfectly sharp tip on it. And then now I'm going to mark this line on the piece of metal. And that's going to help me index the machine, make sure that it's parallel when I put the metal, when I slide the metal back in. I'm going to pay particular attention to make sure I got a really dark line where they overlap, the point where the starting point for the first cut and the second cut are the same. I'm going to run this line the whole length of the metal. Okay, so the biggest piece that I'm going to cut is just under 29 inches. So I'm going to come over here and I'm going to mark off just over 29 inches, and that is going to be my reference. That's going to be my start point for all of, or my 0 point for all my cuts. That way, if I'm cutting later on and I get lost on the sheet or something like that, like let's say the program crashes, I can come back to this point now and zero it out and then go and continue my cuts. Sometimes the fire control will just shut down and you will lose your 0 point. Now I can come back to that point and say, here's where you were at 0, and then we'll try and start over the cut, and maybe that could save us from losing the whole sheet during a cut. So this next step, what I want to do is I want to make the sheet perpendicular to the travel of the gantry. To do that, what I want to do is I want to bring the tip of the nozzle right on top of, down on top of that line that I drew earlier, all the way down the side of the sheet. The problem is that the very tip of the nozzle is like 3/8 of an inch or something like that. It's a big piece. I really can have a hard time zeroing in on that line. So what I did is I went to my 3D printer and I printed out just this little slug that I can simulate the nozzle with. The nozzle of the razor weld torch is 1 inch in diameter. So I made this piece 1 inch in diameter also, and I just put a point on there, a really sharp point. And that way, as I bring this thing down, I can really accurately tell exactly where the center of the torch will be when I put that back into the machine. I printed this thing out. I have a Creality Ender 3D printer. If you don't have one of those for your shop, you should get one. Check out my tooltips is the first one, where I show you how to basically, for about $200, be printing out stuff like this in your garage. And I've got all kinds of tools that I've made with that Ender 3. Now that I have that thing in there, now I can zero in super close to that line. What I'm going to do is I'm going to put it right over top of that line, and once it's there, now I'm going to go ahead and speed the machine up a little bit, and I'm going to run it down the sheet. And if it diverges from the line, one way or the other, then I know that it's not parallel or perpendicular to the gantry. In this case, that tip of that slug is traveling right down the line perfectly. And so now I know that this sheet, or at least this line that I've marked on the sheet, is perpendicular with the gantry. Now I can bring that tip right over top of that little mark I made at 29 inches, zero out the machine, and then now I'm ready to cut. And then when I come back around and I open another program and I slide the sheet and I go right back to that point again, then I know I'm starting from the exact same point and I can just cut the opposite direction. And that's how I'll index it. I know that there are guys that are using index pins and those kinds of things. This is just a way that you could do this without having to modify your table, which I think would be kind of difficult, especially with the water table that comes on the CrossFire Pro. Okay, so I've run this thing back and forth down this line, and it is absolutely perpendicular now to the gantry, the plate metal is. And I've run this also, this other line here. I'm gonna bring the tip now to that line and zero out all the axes, and now I know that this right here is gonna be my XYZ 0 in case I get lost anywhere on the sheet. Let's go ahead and bring it back, and then I'm gonna swap out the torches and get ready to cut. So I don't normally do this on all my cuts, but I am gonna run one practice cut really quick just to make sure that it is working. So what I'll do is, I left the torch off. I also came in here and I turned off the torch height control. Here's the G code on there. Let's go ahead and see what it does as I hit the play. And you'll kind of see as it jogs over, it'll do, so it starts at its XYZ 0, or at least it's X and Y 0. It's gonna jog over, drop down, it's gonna do its, it's gonna fire the torch and then come in. So let's go ahead and watch as that goes here. And so I'm really kind of going through this process to make sure that as it's going, I'm watching the torch and how it goes. I'm watching to make sure that the fire control doesn't crash. So if it crashes later, I know it's because of some kind of electromagnetic interference that's going on. But I'm also kind of watching the cables back over here and making sure there's no binding, because I move the table around a little bit, making sure it's not pulling too much on the cables here. It's not pulling the torch around, which will give me some quality issues there. So once it goes through the whole program, I'm gonna make sure that it'll go back to the XYZ 0, and once it does, I can go ahead and start making the real cuts. One last running through the checklist before I get going. The computer is good to go. I got the green lights here for the torch height control and also the CrossFire. The program I wanted is loaded. It makes sense. I've run a practice run. I've rebooted the computer. The only thing running on the computer right now is fire control, nothing else that caused any problems. I got the compressor going. It is plugged in and ready to go. Runs air all the way to the machine. You can hear the plasma cutter is running. I'm grounded to my piece. Everything's clear and got fans ready to go for air to blow air through here. Got my glasses ready. It is time to cut. So I need to cut 4 of these. So the torch has just stopped, it's finished the program. I'm gonna come over here and I'm gonna say, go to the XY 0, and I'm gonna send it back to its starting point. Now what I wanna do is, this piece is 5.5 inches wide. I wanna jog it 5.75 inches to the right. I've kind of put my little decoder ring here for which way it goes when I put the values in. So with those values, I know I want to move it in the x-axis. I want to go ahead and select this over here, and I want to tell the torch, I think I'm telling it is that it is in negative 5.75 inches. And so I've told it, hey, torch, you're off the side of the sheet. Now, once I have it there, I'm going to go ahead and say, now go to the XYZ 0, and now it's going to jog it over exactly 5.75 inches. And I'm going to continue doing that. And you can see now, if for some reason the torch gets lost, I can go back to that initial point that I have over here, zero everything out, and I keep going over 5.75 inches until I get back to the cut, whichever one I'm on. Let's go ahead and do the second cut. So while this cut is going, I'm just sitting back and watching it, and everything is running really well. And I think the reason that it is because I restart my computer before I start cutting. And that restart just seems to clear everything out, and then I only open fire control. I don't have Fusion 360 or anything else running in the background, just fire control. And that seems to have eliminated all of my frozen fire control problems. Well, I don't know if you could tell it from my voice. I'm pretty nervous about this cut because, as you can see, this takes up the full 3/16 sheet of plate. Now, it's only going to be about a little over 5 feet of plate being cut, but the 4.5 feet wide, you know, it's over a little over $100 of steel. And so far,
working really good. Don't want to jinx myself. Now I got to move the sheet. One thing I did is, since all these pieces are going to be dangling off the edges, I just put a piece of wood across the bottom just to catch them, especially as I do the second cut. If they drop off, I don't want them to start bouncing around and affecting the machine. So I just put that little piece there. And then also, if you're like me and you can't find help, sometimes you're out in your shop by yourself having to move a sheet of plate. How do you scoot this thing across the table without moving the table and messing everything up? What I'm gonna do is, I got this work stand here. I got the roller, I have it set just slightly above the work bed. And so now as I lift the other side, I should just be able to roll it down and put it into the next position. Okay, before I start the next cut, a couple little jobs I'm gonna do. First off is I'm gonna go ahead and pull the plasma torch out. I'm gonna put that plug back in there because I'm gonna use that again to find myself right back here at the original XY 0 points. I'm gonna put that plug right back in there, lightly tighten it down. And then also while I'm here, the torch, the cup, I'm just gonna go ahead and clean it off with my hands and get that clean. But since this is a big cut, I'm just gonna go ahead right now, pull out the electrode and the nozzle and go ahead and replace those, just because it's such a expensive cut. I wanna make sure I have new consumables for the second half of that, just a couple bucks for a little bit of insurance there. So the nozzle doesn't want to come out. There we go. Now you're out. And again, for those who didn't see episode 2, I'm just using the standard Hypotherm stuff that it comes right with the manual for the razor weld for this. And I find the best prices and easiest way to get it is just on eBay. So I've got that. I've also got in an order for a new machine. I think they call it a shield right here. And then also a swirl cup also, although those things seem like they've been doing pretty good. I haven't had any problems with those. But first, let's go ahead and zero in this dummy plasma torch right here with the needle right on that XY0. So step 1 to truing this thing with the table is to make sure that the plate, again, for the second pass, is again, that line is absolutely perpendicular to the travel of the gantry. So if you can look down here, I have the tip of the little slug that I made exactly over the line. Now what I'm gonna do, I'm gonna raise it just a little bit. I'm gonna bring this all the way down the line and make sure that it is, again, absolutely right on that line again. And if you look, you can kind of see that it is just slightly, ever so slightly, to the left of the line. So now what I'm gonna do is I'm gonna grab the whole piece of steel, the whole plate, and I'm gonna just try to shift it just a nudge it over, and then I'm gonna run it back to I'm gonna recenter it, run it back to the other side, and I'm gonna keep doing that until that thing stays right on, until it stays right on that line going back and forth. And then I'm sure that the plate still is perpendicular to the travel of the gantry. Okay, after running it back and forth about 3 times and just nudging this around, I think I'm so close it's less than the width of the mark of the pencil. So I think that's pretty good. And that's important because that air will compound itself as this thing travels down in the y-axis. So as I continue going down this line right here, if I have an error on this line, it'll compound itself. Fortunately, it won't be any greater, just kind of using some right triangle type stuff. If I'm off by 64th or 64th on the extreme on this end, then I'll only be off by 64th on the extreme on the other end. Now what I'm gonna do is I'm gonna go ahead and line the tip of that thing up with the second line, which is the X axis. Once I have that, I'm back to the original 0, and now I can just start cutting just like I did. Just the I'm going to cut the other sides of the trailing arm. So now that the slug here is marking perfectly that it's on the original X and Y axis, I'm going to go ahead and take it out and replace it with the plasma torch. And then now this thing should be zeroed out pretty much right at this exact same point, pretty darn close to it. Once I have this thing in here, what I'm going to do is I'm going to go ahead and just run the whole cut on a test without the torch firing, and make sure that it's going to line everything up, and it should be ready to go. As I tighten this thing down, I kind of wiggle the torch around just a little bit to make sure that there's no play in it, just really lightly, because I don't like to mess with the X-axis too much. Don't put too much force on anything that's fragile. Let's go and try it out. All right, so I've turned off the torch height control. The plasma cutter is off, so it won't fire. I'm gonna go ahead and hit start. And again, I'm looking for kind of the same thing. I'm looking for, A, is it going the right way, the way I expect it to cut? Does it look like it's lining up? Is it going parallel right down that line like I want it to? And then also, as I'm going to the other extreme of this table this time, is it gonna pull the cable for the plasma cutter and take it out of true? Obviously a machine torch would do a little bit better, but just if you watch this and you're careful, I think you do just fine with a hand torch on all these cuts. And then just kind of watching all the cables, making sure nothing's gonna bind up. The program's doing what I expect it to, and it sure is. So once it comes back around, I think we'll be ready to make all the next cuts. No pressure. All right, looks good. We're ready to go. I'm gonna go ahead and send it back to XY 0. It's back at that point. We're ready to go. Here's a telltale. If at the end of this cut, those lines are perfect, then we're doing good. Let's check it out, see how it does. Well, here's the result. I think it's pretty close. I'm welding through that anyway. If you're trying to make a sign or something like that, you need perfect edges. You might be able to sand that down and still be happy with it, but since I'm welding through it, that'll be easy to cover that. Super happy with how they lined up. It came out awesome. There was so much stress in that cut. It came out really, really good. If you can see, I was kind of hitting it here, and then as I get a little bit closer, you can see it kind of misses it just a little bit. And I actually don't even catch it until it comes all the way over here. And then I tell it, hey man, why don't you just nudge over about 0.02 inches, and then it just started lining up those lines really good. So you just gotta kind of watch it if this is the kind of cut that you're doing. But man, I am so happy. So much stress here. This is, I don't know how much money this still costs, but it was quite a bit. And the fact that the Langmuir systems did perfect. Now, if you see it right at the beginning, I did have a torch misfire. It didn't fire. That wasn't a problem with Langmuir systems. That was a problem with the torch. And what I think that it was, one, I changed out the electrode again to make sure that wasn't what it was. I don't think that was it. But there was this little, this connector right down here, which I think might be the torch fire. I'm gonna go ahead and check it out real quick. But that was just a little bit loose. I just tightened that up and made sure all the connections were tightened. I cycled the power of the plasma cutter on and off, and then it just worked. You saw it did the full cut, and man, super happy. This thing can cut things longer than 33 inches and do it really well. I never thought making a cut like that could be so stressful, and I'm so glad that it worked. And now you can see on the J10 race truck behind me what those trailing arms look like in place. Now, I know whatever project you're doing is probably not the same that I am doing, so you're not going to tackle the problem the same way. But maybe in this video, you learned some tricks along the way that you think might help you solve whatever problems you're working on your own build. Just some final thoughts. First off, anything I talked about in the video, I have a link in my description. I'm an Amazon affiliate and I get a kickback if you purchase that, including the 3D printer, which if you don't have one of those, especially as a builder, if you're a guy that has Langmuir systems, the CrossFire Pro, you probably need a 3D printer also. They're super easy to use. Use the same software with Fusion 360 to generate the code, and you can just make so many cool parts. One more thing, there's a lot of video content that I've had here so far, so if you're one of the guys who's watching this as a Langmuir Systems video, there are a lot of other videos where I'm using the plasma table to make the spindles, the steering system, upper and lower suspension for the J10 race truck. If you want to follow along, you'll learn some really cool things. Some other things that I'm doing also is I just started using the BendTech software. You can see I got the roll cage construction going on behind me, and I'll be making a couple videos on how to make BendTech and how to make tube steel do what you want it to do. So I got to get back to my build. I'm just under 2 months until I got to have this thing ready for the Baja 1000, so a lot of pressure is on. A lot of guys coming from all over the world to help me drive this truck. It's really exciting. Hopefully you'll follow along in future videos. With that, please don't forget to hit the like and subscribe button. We'll see you on future episodes. Take care of yourself.